get rid of this 2 here, you divide both sides by 2, you get that y is equal to 3. But that's a starting example, so that's really easy. But let's look at another example here, where I give you know that y minus 3 is equal to 2y plus, say, 7 here, right? To solve an equation like this, you realize that I have y's on different sides of the equation. What we're going to do, we're actually going to group the y's on one side, because that's what the rule says, and group the numbers on the next side. It doesn't matter which side you group on. Don't make nobody tell you no. It really don't matter which side you group on. You get the same answer at the end of the day, right? So when I group on, say, either the left or the right, you're always going to get the same answer. But I'm going to demonstrate grouping on the right-hand side. Ready? So I want to carry this y over here to the right-hand side, right? But I need to carry the 7 to the next side of the equation. So when I do that now, let me just write the minus 3 that was already there. When I carry the positive 7 to the next side of the equation, that becomes a negative 7. The 2y is already there, so I'm just going to write that at the front, so 2y. When I carry the positive y to the next side of the equation, it gives me a minus y. So when I simplify this now, folks, negative 3 minus 7, that gives me minus 10. You owe 3, and then you go back, go borrow 7 more, so you owe 10 now, right? Then I'm going to have 2y minus y here. You have 2, you give it 1, you only left back with 1. So the value for y there is a negative 10. And then the final form in which we can ever ask you linear equations is something like this. Example 3 here. What if I gave you something like 2 bracket y minus 1 is equal to, say, 3 bracket y plus 2? What you'll have to do is expand the brackets, group, and then solve. So expanding the brackets, you're going to take your 2 times y here, which gives me 2y, then 2 times negative 1 here, which gives me a minus 2. So that's the first part. Ready? Expand over here now, I'm going to get 3y here. Then expand over here now again, I'm going to get plus 6. So simply what we did was basically reduce it to something like what we had from before. So same algorithm. Group y's on one side, group values on the next side, and then solve. So because I grouped y on the right-hand side for the second example, I'm going to group now on the left-hand side. So that means I need to carry the 3y over here, and I need to carry the negative 2 over there. Sorry. So I already have the 2y in the equation, right? Carry the minus 3y over here. Cool. Then when I carry the 6 now, I'm going to get 6. Then carry the negative 2 to the next side, I get a plus 2. I'm going to get that a minus y is equal to a positive 8. But you're probably tempted to stop here. Don't. Because we're actually solving for a y and not a negative y. So I need to get rid of the negative value here. So I'm going to divide by negative 1 from both sides. Negative cancels negative, right? So that gives me a positive y now is equal to 8 over negative 1, which will give me a negative 8. So in essence, that's all you need to know for linear equations. That's everything that we could possibly ask you for an exam or anything of the sort. All right. Now, quadratics is very short. All you need to remember is that a quadratic equation is any equation where the highest power is 2, so ax squared plus bx plus c, where a is not equal to 0. So this is the general form of a quadratic, right? So I figure more or less they'll only ask you to solve a quadratic. So to solve a quadratic, we have 4 different methods, but on an exam paper, we can only ask you about 2 or 3. So the 4 methods are factorization. I hope you know to factorize. The next method would be the quadratic formula, the quad formula. The next method is completing the square. Highly unlikely that they'll ever ask you to complete the square. So completing the square. And the next method is a graphical method, which nobody's going to ask you that on an actual exam paper. So I'll recommend that you focus on the first 2 here, but I'll also recommend that you know the quadratic formula. The quadratic formula is the mother of all methods because it will always work. So if you remember the quadratic formula, it is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. All right, so focus on this formula for the topics of quadratics, and that should be able to help you out when you're trying to solve equations. All right. So I'm going to go down to the matrix algebra. Matrix algebra because I figure this is where he would probably test most of the content. On the matrix algebra, I'm seeing on your syllabus where you have matrix addition, multiplication, and transposition. So I'm going to start with the easiest thing of all of them, the transposition here. So see, I have a matrix A, right? And I have, say, a number 1, 2, 3, 4 here. Cool. The transpose of the matrix is found by basically flipping the rows and columns. So transpose is found by changing the rows and the column, right? So what does this mean? So if it was the first row now, it's actually going to become the first column. And if it was the second row, then it becomes the second column, right? So if I look at A here and I want to find the transpose of A, we write it as A with a T in the upper top here to mean A transpose, right? And how do I get that? Remember, you just basically change rows and columns. So this here is my first row, so it's 1, 2. It becomes now my first column, so it's actually going to change orientation and it's going to go down as 1, 2. This here is my second row, which is 3, 4. The row now becomes a column, so it's going to be the second column. It would give me 3, 4 as the second column. So that's how you get a transpose matrix, all right? But it won't be so simple you have a 2 by 2. So what if I give you a 3 by 3 and ask you to transpose it? So what if I had -1, 0, 3, 4, -2, 5, 7, say 3 here now, and a -9 here. So if I ask you to find B transpose, how would I go about doing that? So B transpose now, remember, the rows now become your columns, right? So let's work with the rows. So the first row here is -1, 0, 3. It becomes my column, so that's actually going to give me -1, 0, 3. So remember, rows become column. That's how you do transpose. The second row here is 4, -2, 5. That now becomes a column, so it becomes a column with 4, -2, 5. The third row here is 7, 3, -9. Third row becomes the third column, so it is now 7, 3, -9, and that's how you find a transpose to any matrix. All right. So the transpose, simply guys, is that the rows become columns or columns become row. It's the same thing. They're both equivalent. All right. So that's how you find the transpose.